Hello and welcome back to our channel guys. Today we are going to see design calculation for base plate. For ISMC 200 column we have already done a design calculation for axial loading. Please kindly do check this video in our list. In base plate calculation, today we are going to first determine the base plate dimensions, then calculate thickness of the base plate. Then we will also design anchor bolts for the base plate. Then we will check a bearing pressure generated by the load through base plate on concrete. And finally, we will conclude the base plate design. Now guys, in given, we have some already assumptions made. Column size, we have taken ISMC 200, which depth is 200 mm and width is 75 mm. Load on the column is 1000 kg, which is vertically downward and concentric at the center. Now we will see how to determine the base plate dimensions. As this figure shows, we have taken this ISMC 200 by 75 on this plate and given a 50 mm dimensions or space to the all sides to maintain the welding all around the column and give a space to the anchoring purpose for holes. This ISMC 200 we have taken and length of the plate we have determined by 200 mm plus 50 mm into 2 equals to 300 mm at one side. Then we have taken the width is 75 mm plus 50 mm each side is 175 mm at this side. So the base plate dimensions become 300 by 175. This way we determine the base plate dimensions usually. It varies depend on the need of the base plate. If you want to put some gussets all around to strengthen the column with the base plate, then the dimension will vary. Now we are going to calculate the thickness of the base plate. The thickness of the base plate can be calculated using the formula of bending stress. Assuming the base plate act as cantilever beam over the area of anchor bolt. In given, there is a applied load which is we have already considered 1000 kg. To convert that kg into Newton, we have multiplied that by 9.81 Newton per mm square. Now we get the value of load in Newton is 9800. Length of the base plate, which is 300 mm, and width we have already calculated 175 mm. Now, assuming the base plate bending stress 185 megapascal, which commonly used for mild steel. So this is we have taken from the mild steel catalog. Formula for thickness is nothing but T equals to under root of 6P into E divided by Fy into B. Now we will see the notations given. E is nothing but the eccentric distance of the plate from the column center. This is for cantilever assumption. Fy is nothing but a yield strength of the material, which is 250 megapascal for structural steel. This is again a catalog value as like a bending stress. Now assume that E equals to 300 mm by 2, which is this 300 mm, and by 2 is nothing but we are dividing that into half. So E equals to 150 mm. Now while calculating T, we are going to put all these value into the formula of T. As we know, the formula is 6 into P into E. So 6 into P is load 9800 Newton and E we have just calculated is 150 mm, which is divided by Fy into B. Fy is nothing but the yield strength which we have taken from catalog 250 Newton per mm square. This 175 is nothing but a B, which is a width of the plate 175 mm. Calculate this and get the thickness T is equals to 14.2 mm. For safety purpose, we are going to round up this T into 16 mm. So T, which is a thickness of the plate, we are going to consider a 16 mm. Now we will design an anchor bolt for the same base plate. While designing the anchor bolt, size and number of anchor bolts are depend on the load and size of the base plate. Assuming using 4 anchor bolts for this plate. This is the assumption we have made. You can utilize a 6 number of bolts or 8 number of bolts depend on your design. Size and number of anchors. Assuming the load is evenly distributed. Load per bolt equals to P upon 4. So 9800 divided by 4. 4 is nothing but the number of bolts we have taken. So each bolt will going to take a load of 2450 Newton. Using an allowable tensile stress which is 150 megapascal for bolt, this is again a catalog value. We are going to calculate A is area equals to load upon allowable tensile stress. So 2450, this value comes from the each bolt loading divided by 150 Newton per mm square. So this way we are going to get a value of 16.33 mm, which is a area of the bolt. In this condition, we have taken M16 bolt for this plate whose area is 152 mm square. We required only 16.33 mm square. This value comes from catalog, I mean bolt catalog. So this way we are designing a anchor bolt. Now we will check for the next design, which is a bearing pressure on concrete. Definitely guys, when the base plate is getting a load of 1000 kg, it's going to exert the pressure on the concrete beneath. So this pressure also need to be get calculated. To ensure the bearing pressure on the concrete is within permissible limit, because if we don't ensure that, the load will break the concrete. So we need to calculate a bearing area for that. For calculating a bearing area, we need to first take the base plate area, which is 300 multiplied by 175. This is the length and width of the plate. Now area comes 52,500 mm square. Bearing pressure equals to load upon bearing area. Load is nothing but 9800 Newton divided by 52,500. The value comes 0.187 Newton per mm square. This is within the permissible bearing pressure of concrete, which is usually 4 to 5 Newton per mm square. So the given bearing pressure or exerted bearing pressure on the concrete is far less than 4 to 5 Newton per mm square. So our concrete design is safe in this case. So final design specifications come to base plate dimensions. We have concluded we are required 300 by 175 mm plate. Base plate thickness we have calculated 16 mm, and anchor bolt 4 numbers we have calculated M16 bolts. So this way we can design our base plate easily. Utilizing the same design, you can take your column sizes and design your base plate accordingly. This is it guys. Thank you very much for watching this video. Kindly like and subscribe to our video and hit the bell icon button to get our latest video on time. Thank you very much. Hello and welcome back to our channel guys. Today we are going to see design calculation for base plate. For ISMC 200 column we have already done a design calculation for axial loading. Please kindly do check this video in our list. In base plate calculation, today we are going to first determine the base plate dimensions, then calculate thickness of the base plate. Then we will also design anchor bolts for the base plate. Then we will check a bearing pressure generated by the load through base plate on concrete. And finally, we will conclude the base plate design.